Open a terminal on almost any machine right now, and you will find curl. It ships natively on Windows, Mac OS, every Linux distribution, and billions of embedded devices. It is the workhorse driving continuous integration pipelines and automated servers globally. Created by Daniel Stenberg in 1997 to automate fetching currency exchange rates, the name originally stood for Client URL. Despite its ubiquity, developers often treat curl as a black box for generating magic strings, or mistakenly view it as a simple file downloader in the vein of wget. That view ignores its actual architecture. The curl command line interface is a thin, transparent wrapper. Below it sits the true engine, a library called libcurl, built to handle over 25 distinct network protocols. This architecture is built on a requirement for explicit instructions. A web browser is designed to make assumptions on your behalf, automatically following redirects, storing cookies, and negotiating security. Curl does none of that. It executes the precise network interaction you request, with zero assumptions. Mastering this tool does not require memorizing an endless list of command line flags. It requires understanding how those flags explicitly map to the network protocols they manipulate. A standard curl command initiates a GET request, and by default, dumps the raw output payload directly to your terminal's standard output. To override this and save the data locally, you use the output flags. A lowercase -o allows you to specify a custom file name, while an uppercase -o extracts the file name directly from the remote URL. If that URL results in an HTTP 301 or 302 redirect, curl ignores it. Because it makes no assumptions, it will only return the redirect header. To force the engine to follow the redirect, you must pass the -L or location flag. When a request fails, you need visibility into the connection. The verbose flag -V is the primary tool for this. This split screen shows what -V exposes. Asterisks and angle brackets map to the network handshake, showing DNS, TCP, and TLS in real time. If headers aren't enough, --trace ASCII pushes deeper. It dumps the raw packet payload, letting you inspect exact bytes hitting the wire. Conversely, if you only want to quickly check a status code without downloading a payload, the -I flag tells curl to send an HTTP head request, fetching only the response headers. Using these three diagnostic flags together creates a transparent view of the entire transfer process. To interact with APIs, you need to alter the HTTP method. The -X flag allows you to override the default GET request and specify POST, PUT, or DELETE. Using -X alone is a common pitfall. This flag only changes the specific text of the method header. It does nothing to change how curl formats or handles the underlying data. To actually inject data into the request, you use the -D flag. This automatically formats the payload as standard web form data and switches the default method to POST. Standard form data fails when you need to upload a binary file. For that, you use the -F flag, which constructs the multi-part form data payload required by servers accepting file uploads. This diagram illustrates how the --JSON flag physically unpacks. It acts as a shortcut that automatically sets the method to POST, inserts the correct accept header, and formats the content type header for JSON. You can declare a specific user agent with -A and inject any arbitrary custom header the server demands with -H. Explicitly shaping the request body and headers gives you complete control over testing complex REST APIs directly from the shell, without ever relying on heavy GUI applications. When a server locks down resources, you can authenticate using -U for standard HTTP basic credentials, or inject an authorization bearer token directly via a custom -H header. HTTP is a stateless protocol. Browsers hide this reality by managing session cookies automatically. Curl requires manual state management. Capture session state using the -C flag. When the server returns a set cookie response, curl writes it into a local text file, or cookie jar. For the next request, the -B flag reads this file, slotting the cookie data back into the outgoing HTTP headers. When establishing these secure connections, curl strictly verifies TLS certificates by default. But bypassing these checks with the -K, or insecure, flag leaves your traffic entirely vulnerable to malicious interception. The correct secure workflow is to provide the specific cryptographic keys required by the server. You use --CA cert for custom certificate authorities, and the --cert and --key flags to verify your identity in mutual TLS environments. Mastering manual state management and explicit TLS handshakes allows you to securely penetrate and test fully locked down enterprise networks. To scale up operations, curl offers native URL globbing. By enclosing numerical ranges or text arrays in brackets within the URL string, you can iterate over hundreds of targets without writing external bash loops. Historically, this feature had a strict limitation. Older versions of curl executed these globbed lists sequentially, one after the other, creating significant bottlenecks. The -Z flag allows these requests to execute concurrently, utilizing HTTP2 multiplexing to remove the latency overhead of serial transfers. During large data transfers, you can maintain control by passing the -C flag, which instructs curl to calculate the byte offset and resume broken downloads exactly where they failed. If your bulk operations threaten to saturate the network, you can precisely throttle bandwidth usage by appending the --limit rate flag. Ultimately, the combination of globbing and HTTP2 parallelization makes curl highly capable of handling massive, industrial-scale bulk data transfers. Curl is engineered to integrate into automated scripts. The -W, or write out, flag extracts specific programmatic metadata from a transfer, like the exact HTTP status code returned or granular latency timings, and prints them cleanly. As a native Unix pipeline citizen, curl's standard output can be directly piped into specialized processors. Passing a raw API response into a JSON parser like JQ allows you to automatically extract exact values for shell scripting. Version 8.3 introduced the ---- variable feature. This enables dynamic template expansion directly inside the command line, allowing you to pass environment variables and format inputs within complex scripts. To embed into a compiled application, the --libcurl flag generates the exact C source code equivalent of your CLI command, exposing the underlying library calls. While curl is most famous for HTTP, the libcurl engine supports over 25 distinct network protocols. You can send an email directly from your terminal by passing an SMTP server to the URL parameter, authenticating with -U, and pushing the email body as an upload file. Metadata extraction, pipeline integration, and multi-protocol support make curl a foundational tool for back-end automation. This production-grade deployment command uses injected variables, JSON payloads, secure authentication, parallel execution, and write-out formatting. What initially reads as an opaque block of text is now a logical sequence of explicit network instructions. This logic applies to every feature in the tool. For the complete list of capabilities, you can read the internal manual by typing man curl to access all 2,000 lines of documentation. Mastering curl provides a deep technical understanding of the network protocols that move the internet.